So today we are looking at lesson 7-4, and basically we're going to concentrate on properties related to logarithms. So we use these properties in order to solve equations. So this is a baby step, a building block to solving equations. So they are very important. So let's start off with the product property. So the product property just means, so if you remember that multiplication and addition are closely related, division and subtraction are closely related. And if you kind of think about exponent rules, they're very similar to these product property rules. So when you multiply like bases, you add the exponents. So we can pull apart this log into two different logs. So we're going to take log base b of m and add to that log base b of n. And so you ought to be able to go forwards and backwards with that. If I have two logs that I'm adding, I can take their arguments, the m and the n, and multiply them together and make one log. If I have one log where we're multiplying, I can split that into two different logs by using addition. So here the word is condense. Condense means to make smaller. So we're going to condense into a single logarithm and simplify if possible. So I'm going to make this much bigger so you can see. And I am pretty much going to go through every single example. You can fast forward through the ones that you don't need, but they go fairly quickly. For this particular example, we're condensing into one log, and so since we have addition, we're going to multiply the 7 times the 4. The bases stay the same, so you've got 7 times 4, and so that's going to give you log base 2 of 28. So that's all they want to do is just get it into one log. We're going to use this skill in solving equations, so that's why it's important. So you go ahead and try 2 and 3 on your own. Pause the video and try those and check your answers. Alright, so this is log with base 10 because you don't see the base of 25 times 4. So that is log 100. So for number 3, we're going to have log base 4 of 2x times 4x squared. So remember, we're going to multiply coefficient to coefficient, like base to like base. When we multiply like bases, we add the exponents. So you end up with log base 4. 2 times 4 is 8. X to the first times x squared. If you add those exponents, is x to the third. Now, for questions 4, 5, and 6, we're going to expand. We're going to take this log and stretch it out. So I don't see anything being multiplied here, but I do know that there are two values that multiply to give me 6. 2 and 3. Now you could have used 1 and 6, but we generally aren't going to use 1 and 6. So I generally will use prime numbers. So the log of 6 can be broken into the log of 2 times 3, which then can be expanded through addition, log of 2 plus log of 3. So then you try 5 and 6 on your own, pause the video, and then check your answers. So for 45, you could have written, probably you would have used either 5 and 9. 5 times 9 gives you 45, or 3 times 15. Those are your two possibilities. Most of you will have chosen 5 and 9, I would have thought. So log base 7 of 5 times 9, you can expand that, pull that apart into two logs. And then number 6. Number 6 is already a multiplication problem. You already have multiplication in between the 5 and the x. So we can just pull it apart using addition. And there you go. So then we're going to look at the quotient property. So for the quotient property, we now have a division problem going on here. So we can tear this apart by using subtraction. So you would have the log base b of m minus the log base b of n. And then you can also go backwards. If you say two logs being subtracted, you can combine them into one log by dividing these arguments. So let's look at an example. So look at number 7. Because we have subtraction, I can take the arguments 24 and 8 and divide them. So you would have the log base 3 of 24 divided by 8. Well, 24 divided by 8 is 3. Now, technically that's one log, but I have also taught you that when the base and the argument agree, that the value of that log is 1. That's going to bring us to another property. So anytime you have the base and the argument agreeing, that's equal to 1. And remember, here's the reason why. If I were to solve for this, remember I would set this equal to x. And then I would put this in exponential form. So this would become 3 to the x equals 3. Remember, this is 3 to the first, so x would have to be 1. Anytime these two agree, the value is going to be 1. So in my personal opinion, this is the answer. I would also accept this for right now. So you do 8 and 9 on your own. And then, so pause the video and check your answers. So for this one, we're going to divide. So log base 2 of 15 divided by 15, and that simplifies to log base 2 of 1. Now theoretically, if you want to think about what we've already learned, if I set this equal to x and put this into exponential form, 2 to the x is equal to 1. The only way that 2 could be raised to any exponent and have a value of 1 is if x is equal to 0. So a second property we're going to add on. No matter what your base is, anytime you're taking the log of 1, so if your argument is 1, the answer is always 0 because this will always occur. So in my be so humble opinion, this is the answer to number 8. I will also accept the one I circled in red. Then number 9. So because we have subtraction, we're going to divide these two. So you get log base 4 of x to the 9th divided by x squared. When dividing like bases, you subtract the exponents where there are more. So there's more up top. So 9 minus 2 is x to the 7th. All right, so let's expand. So let's look at 10. So you're going to use the quotient property. So this time you've got to come up with some sort of quotient that has a value of 4. Well, there's an infinite number of these, so I'm going to replace 4 with 8 divided by 2. So there's a quotient. So now I can tear that apart by using subtraction. So log base 8 of 8 minus log base 8 of 2. Technically we can go further because remember this has a value of 1 because the base and the argument agree. So technically this is 1 minus the log base 8 of 2. But for right now I'll accept this. So you do 11 and 12. Don't let this fraction bother you. You do 11 and 12 because it's actually easier with a fraction because you have a quotient going on here. So split this log apart into two different logs using that quotient. Pause the video and check your answers. All right, so we're going to take the log base 5 of the numerator, 1, and subtract log base 5 of the denominator, which is 3. And it's no more difficult than that. So again, you just took the 1 and subtracted the 3. Log of the 1 subtracted the log of the 3. So the same thing here, we're going to take log of m, because it comes first, minus log of 7. Now we're going to look at our third property, which is our power property. So this is log base b of a power. Anytime you have a power, you're going to take this exponent and loop it in front. Take the n and loop it in front so that we get n times the log base b of m. And so vice versa, if you're trying to compress, you can't have anything in front of the log, you would re-loop it back up here and it would become the exponent of this argument. So let's look at example 13. So example 13, we're condensing into a single log. So anything that's in front gets looped up as an exponent. So this 5 is going to go up here as an exponent. So you get log base 4 of 2 to the 5th. Well, 2 to the 5th is 32, so log base 4 of 32. And for right now, this is your answer. We could actually evaluate it, but they're not asking for that. So you go ahead and try 14 and 15 on your own, pause the video and check your answers. So we're going to loop the 7 up here, so we get log base 2 of x to the 7th. And then for 15, we're going to loop the 1/3 up here, so we get log of 8 to the 1/3. Whoops, that's 1/3. Well, let me try that one more time. How about 1/3? Okay, so you cannot leave a fractional exponent. This can be simplified. Remember, when you have a fraction in the exponent, it means you have a radical. The denominator of that fraction is the index of that radical. The numerator is what this base is raised to. So if I cover up that, it looks like 8 to the 1st. So 8 to the 1st is going to go underneath the cube root. So this is really the log of the cube root of 8. And the cube root of 8 is 2. So this is our final answer. So now we're going to expand. So when you're expanding, all you have to do is take this and loop it forward. And this particular one, I'm going to go even further, but I'm going to take this 7 and loop it in front. So I get 7 times the log base 2 of 8. And really that's all they want for right now. I'm not going to try to confuse you with what the actual answer is, so we'll just leave it at this. We'll leave this as the answer for right now. So for 17 and 18, I want you to try those on your own. For 17, you already have something in front of the log, so when you loop this and bring it in front, you're going to have to multiply it to the 3. So you're going to want to use parentheses. So pause the video, try it, and then check your answers. So I'm going to loop all of this in front, and I'm going to actually put it in between the 3 and the log. So I have 3 times this x minus 1 that I looped in front of the log of 4. So you can either leave your answer like this, I would accept this, or if you're going to distribute the 3 into the x minus 1, you have to leave your answer in parentheses. So for instance, 3 times x is 3x. 3 times negative 1 is negative 3, and your parentheses, and then log of 4. So I would accept this as an answer as well. Now 18, you have to get rid of the radical by making a fractional exponent. So because w is to the 1st underneath here, and the index is 2, this can be written as the log base 7 of w to the 1/2. Again, w is to the 1st underneath here, so that's where the 1 comes from. And the index here is 2, so that's where the 2 comes from. Then you can loop the 1/2 in front. So you get 1/2 log base 7 of w. Let's look at the second page. So we're going to put it all together now. We're going to use all the properties, expanding and condensing. So for number 19, the directions are rewrite as a single logarithm and simplify if possible. So before we condense, we're going to have to loop anything in front of the log up here. So before I can, take this subtraction and convert it to division, I have to loop the 2. So that's first and foremost what you got to do first. So if I loop the 2 up there, I've got log of 6 squared minus log of 9. So then 6 squared gives me log of 36 minus log of 9. So now I can condense by taking this subtraction and dividing these two. So then I get log of 36 divided by 9, which is log of 4. Fully simplified. So then you try 20. Pause the video and try 20. So loop the 4 to the A, loop the 2 to the B. So you get log base 4 of A to the 4th plus log base 4 of B squared. Then you're going to compress by changing the addition into multiplication of these two. I highly suggest that you put that whole argument in parentheses. So A to the 4th times B squared. For 21, it's going to be the same thing, but when you loop it, you're only looping a positive 3, not the negative. So you go ahead and do 21 and 22 and then check your work. When you do 22, by the way, let's look at that. When you do 22, you have to go in order of operations. Order of operations say you go left to right, so you have to compress these two first, and then you can take that answer and compress it with a minus log. All right, so go ahead and try it. All right, so we're going to loop the 7 and just the 3, and so you get log base 4 of u to the 7th minus log base 4. So when you loop this 3 up here, this is a power, and you're going to make it into another power. So remember, a power to a power is multiply. So you're going to multiply the 3 to the 2. So you get v to the 6th. Then you're going to compress these two. It's subtraction, so you're going to take this and divide it by this. So log base 4 of u to the 7th over v to the 6th. And I would put that in parentheses. Then for 22, we have to go in order of operations left to right. So I've got to compress these first. So because it's addition, we're going to multiply. That's multiply. Then minus log base 2 of 6. So 15 times 4 is 60. Minus log base 2 of 6. So finally I can compress these because of the subtraction. I'm going to divide. So log base 2 of 60 divided by 6 is equal to log base 2 of 10. All right, look at 23. So the only difficult thing about 23 is that you're looping a 1/2 up here, but remember that just means it's a root, a radical. So I want you to do 23, 24, 25, and 26 on your own. Pause the video and then go back and check your answers. So before I start, I'm going to have to loop this up here. So you actually get 49 to the 1/2. Remember, 49 to the 1/2 is equal to the square root of 49, which in our case is going to be 7. So I can rewrite this as the log base 3 of 4 plus the log base 3 of y plus the log base 3 of 7. Now, typically we'd have to go from left to right, but it's all addition, so this is all multiplication. So all I have to do is multiply 4 times y times 7. Well, 4 times 7 is 28, so I get log base 3 of 28 times y. So for 24, I would highly suggest that you distribute the log here and here first. Well, that's not true. You could actually compress this first too. It doesn't matter which one you do first. Let's go ahead and compress first. So we've got 1/3 times the log base 5. So since we have addition, we're going to multiply 8 times 7. So 8 times 27, 27. And then minus the log base 5 of 3. So when you take this 1/3 and loop it up here, you actually get the log base 5 of 8 times 27 to the 1/3. Remember that 1/3 means the cube root, and I'm purposely not multiplying 8 times 27 because I'm trying not to use a calculator, and I'll show you why in a minute. So I can actually take the cube root of 8, which is 2, and the cube root of 27, which is 3. So 2 times 3 is 6. So the cube root of 8 times 27 must be 6. So all of this converts to a 6. Then to compress this, all I have to do is divide the 6 and the 3. So I get log base 5 of 6 divided by 3, which is log base 5 of 2. All right, 25. So for 25, we're going to loop the 3 up to the 4. So we get log base 2 of 4 cubed. Well, 4 cubed is 64 minus log base 2 of 32. Because of the subtraction, we're going to divide these two. So we get log base 2 of 64 divided by 32, which is log base 2 of 2, and as we know, this value is equal to 1. Anytime the base and the argument agree, the value is equal to 1. All right, then for 26, you are going to loop the 2 to the 6. You're going to loop the 1/4 to the 16th. So we end up with log of, when you loop the 2, you get 6 squared, which is 36, minus, when you loop the 1/4, 16 to the 1/4 is the same as the 4th root of 16, and the 4th root of 16 is 2, plus the log of 3. So order of operations, say we go from left to right, so I have to take those first and we're going to divide them. So log 36 divided by 2 is 18, plus log of 3. So I just brought this log down. So because of the addition, we can multiply these two. So we get log of 18 times 3, which is 54. So let's expand them. So we compressed on all those, now let's expand. So here I have everything being multiplied. So to expand with multiplication, we're going to use addition. So I have log, and these get long, so log base 6 of x plus log base 6 of y plus log base 6 of z to the 4th. Now the last part of expanding is to take any exponent and loop it in front. So we finally get log base 6 of x plus log base 6 of y plus 4 log base 6 of z. So for 28, to expand, whoops, to expand, we have division here, so we're going to subtract. So log base 4 of a to the 9th minus log base 4 of b. We have to loop this 9 in front. So our final answer is 9 log base 4 of a minus log base 4 of b. All right, so you go ahead and try the rest of these on your own. If you get stuck, go ahead and, fast forward to the part that you need, but do check your answers. So for 29, the easiest way would be to raise these powers to this power first. Don't try to loop this in front, because then you have to redistribute that 2 into what you tear and break apart. So power to power we multiply. So we're going to end up with log base 7 of 4 times 2 is 8. So I get q to the 8th. And then 2 times 2 is 4. So I get r to the 4th. Then because I have multiplication here, I can tear them apart by addition. So I get log base 7 of q to the 8th plus log base 7 of r to the 4th. Then any exponents can get looped in front. And so we have 8 log base 7 of q plus 4 log base 7 of r. For 30, again, I would do power to a power. So I'm going to multiply exponents. So this is to the 1st and this is to the 5th. So I end up with log base 2 of y to the 2nd over z to the 10th. And again, I just did 1 times 2 is 2, 5 times 2 is 10. Now I can tear these apart, since they're division, by using subtraction. So log base 2 of y squared minus log base 2 of z to the 10th. Swing any exponents in front, and you're done. So 2 times log base 2 of y minus 10 times log base 2 of z. (31). Anytime you have a radical, you've got to get rid of that radical by changing it into its fractional exponent. So remember, we're going to take all of this. So you're going to take log of 7x cubed. You're going to take all of that and raise it to a fractional exponent. So you're going to consider all of this being raised to the 1st power. And then the index here, which is understood to be 2, becomes your denominator. So the exponent that you raise it to is the 1/2. Don't forget that the 7 is to the 1st power. And it would be easier to do power to a power than trying to loop this 1/2. So I'm going to multiply it power to power. So 1 times 1/2 is 1/2, and 3 times 1/2 is 3/2. So you end up with the log of 7 to the 1/2 x to the 3/2. I just multiplied power to a power. Then you can expand them by using addition. So log of 7 to the 1/2 plus log of x to the 3/2, and then finally loop in front these exponents. So we get 1/2 log of 7 plus 3/2 log of x. And last problem before we recap everything. Again, we have log base 3 of m to the 5th n squared. And all of that is going to be raised to a fractional exponent I'm going to assume that all of this inside of here is raised to the first power. The index is 4, so a 4 goes in the denominator. Power to a power, you want to multiply exponents. So I'm going to end up with log base 3 of m to the 5/4 n to the 2/4, which is 1/2. Then you can split this by addition. So log base 3 of m to the 5/4 plus log base 3 of n to the 1/2. Loop those exponents. And your final answer is 5/4 log base 3 of m plus 1/2 log base 3 of n. All right, so let's recap and look at the last page of your notes. So here we have a recap of the properties, and I'm going to go ahead and make this bigger just so that you can, really kind of see a little bit better. But your basic logarithms, we talked about this before. Let me see if I can straighten this. Okay, so for your basic logarithms, when your base matches with your argument, the answer is always 1. If you're taking the log of 1, it doesn't matter what your base is, but anytime the argument is 1, the value of that log is going to be 0. So go ahead and pause the video and complete these 2 examples. So there are your answers to the first row. So then look at our product rule. So remember, for our product rule, you can expand your logs by addition. So log base b of m plus log base b of n. So go ahead and pause the video and perform these 2 problems here and then check your answers. So if I condense these, I have log base 5 of 6 times 7, which is 42. And then here I'm going to expand this, so you could have used 3 times 21, or 6 times, not 6, I know my times tables, 7 times 9. So either of those 2 you could have used. It doesn't matter which one. Most of you will have used the 7 times 9. So I'm going to expand that by making this 7 times 9. So I have log base 2 of 7 plus log base 2 of 9. All right, so for our quotient rule, remember that we can expand this by doing subtraction. So log base b of m minus log base b of n. So complete these 2 examples, pause the video and check your answers. So here we're going to take 84 and divide it by 12, and we get 7. So this becomes log base 4 of 7. And then here you've got to create a quotient, and so there's an infinite number of items that will divide to give you 9. So I'm just going to give you, I don't know, I'm going to replace this with 81 divided by 9. It doesn't matter what you choose, so long as you choose a quotient that divides to give you 9. So then I can expand this by doing log of 81 minus log of 9. So then here, your power rule. Remember, with the power rule, that just means that we're going to loop this out in front. And so we end up with n times the log base b of m. So try these 2 examples and then check your work. So for condensing, I'm going to loop this up here, and I end up with log base 3 of 8 squared, which is 64. For the second one, I have to take the x minus 1 and loop it in front. Make sure you use parentheses. So x minus 1 times the log base 2 of 6. Then your change of base formula. So that would be log of A divided by log of B. So we immediately convert to a common log of base 10 and just divide those two. So you go ahead and use the change of base formula for this expression and then check your work. So you should have log of 32 divided by log of 7. And that is approximately equal to 1.7810. And then the final thing I'm going to say, make this smaller, even smaller. Okay. So remember that it is important that you remember that base 10 logs are common logs and they are written without a base. And so this is what they look like written without that base. And that's it. So good luck with your homework and just let me know if you have any questions.